Okay, class, I'll be going on to chapter 6, 6.1 of E-Maths, and I'm going through the basics with you again, okay, so that you're not so confused. Now, in set 2, we learn about toa, ka, so, alright? Toa stands for tangent and is opposite over adjacent. Cosine, ka, adjacent over hypo, and so, sine, opposite over hypo. Now, the opposite and adjacent is with respect to the angle theta. Okay, hypo is always the longer side and is opposite the right angle. Okay, now, then I have introduced to you some terms here the other day that I said for the 4 quadrants here, this is the first quadrant, this is the second quadrant, this is the third, and this is the fourth quadrant. And I also told you that it is going according to CAST. Now, what do we mean by CAST? A stands for all positive, S stands for sine positive, T stands for tangent positive, and C stands for cosine positive. Now, all of you please take note. Angles are measured with respect to this particular positive x-axis. If I have an angle here, that means this angle is measured from here to here and it is acute. If I have an angle over here, that means I'm measuring from here to here. So this is an obtuse angle. Okay, now I repeat, angles are always measured from the positive x-axis. That means angles that's over here is measured from here to here. That means they are acute angles. And angles over here is measured from here to here and they are obtuse angle. Now, that means angles in the first quadrant are acute, angles in the second quadrant are obtuse. Okay, let me use another color to illustrate to you again. Alright, now all of you take note now. This is an acute angle over here, but if I measure from here all the way to here, it means it's an obtuse angle. That means acute angle has all sine, cosine, tangent positive, but an obtuse angle only has got sine positive. The rest are all negative. Okay? Alright. Now, next, I'm going on to the concept of basic angles. Alright? Basic angles. Okay? What do you mean by basic angles? Now, basic angle is the angle that the line makes with the x-axis. Angles with the same basic angle have the same numerical trigonometrical values, just that the sign changes according to the quadrant that it is in. Okay, now this one looks like very difficult, but let me explain to you with numerical terms. I repeat, basic angle is the angle that the line makes with the x-axis. Angles with the same basic angle have the same numerical trigonometrical values, just that the sign changes according to which quadrant that it is in. Okay, now I just want you to consider this particular example here. Okay, and I hope that this will clarify all the doubts that you're having. Okay, I hope that this will clarify all the doubts that you're having. Now, for example, this is angle 60. Okay, this is also angle 60. These two are basic angles, angle 60 here and here. Now, for an angle to be having basic angle 60 is 60 degrees in the first quadrant. Okay, so 60 degrees in the first quadrant. Now, if an angle has a basic angle of 60 degrees in the second quadrant, that means the angle is actually 120 degrees. This whole thing, basic angle 60, the whole thing here is 120 degrees. Okay, now, this is exactly what I've written down here. I will consider only the first 2 quadrants. Now, in A-Maths, then we will look at the third and the fourth quadrant. So for right now, we will just consider the first 2 quadrants. Now, let's take a look at this part here. Note that 120 degrees has basic angle 60 degrees. Okay? Now, let me just show you the diagram again. Alright? let me just show you the diagram again. Now, 60 degrees here, this line, 60 degrees. Sine 60 is this value, cosine is this, tangent is this. 60 degrees is in the first quadrant, therefore all ratios are positive. Okay, now if you have 120 degrees, that means it's going to the second quadrant. Second quadrant, only sine is positive. Only sine is positive. So these are the values that it will give you, sine, cosine and tangent. Now I want you to compare this set of values with this set of values. The numerical values are the same, just that the sign changed here. Now, can you see that 60 degrees is acute, first quadrant, so all are positive. 120 degrees obtuse, second quadrant, only sine positive, the rest are negative. But note that the numerical values of all are the same. I repeat, angles with the same basic angle have the same numerical values, just that the sign will change according to the quadrant that it is in. Okay, alright, now next, I'm going to example 1 of your textbook. Alright, example 1 of your textbook. Okay, now let's take a look at this particular example. Example 1 of your textbook. Okay, now let's take a look. They tell you in the question that sine 55 degrees is 0.819 and cosine 136 degrees is this. Now, I'm going to draw this first one first, 55 degrees. So 55, 55. Okay, now everybody can take a look at the picture first. 55, 55. Now, if it is 55 here, okay, and 55 here, this whole thing will be 125. If basic angle is 55, this obtuse angle will be 125. Because this is a straight line, these two must add up to 180. Okay, now, note that the basic angle of 125 is 55 degrees. So, since sine 55 is 0.819, sine of 125 will also be 0.819. Okay, the numerical value is the same. This side is all positive, this side is sine positive, therefore sine of an obtuse angle is still positive. Now note that these two angles add up to 180 degrees. Alright, now feel free to pause the video if you need to recap certain concepts. Now let's look at part B. Okay, what does part B says? Okay, now they tell you that cosine 136 is negative 0.719. Now 136 is in the second quadrant. That's why only sine is positive, cosine is negative here. Now, don't forget, if it's 136, this is 44, and this one will be 44 too. Okay, if I draw an angle here 44 degrees, 136 has basic angle 44, and 44 degrees has basic angle 44 over at the first quadrant. Now, the question asks for cosine 44. Now, cosine 136 and cosine 44 will have the same numerical value, but because 44 lies in the first quadrant whereby all the ratios are positive, therefore I only take 0.719 and not negative because this is in the first quadrant whereby all the ratios are positive. Okay, so please take note of that. Okay, now what does it mean? That means angles that are acute and in the first quadrant have all three ratios positive. Angles in the second quadrant, which are obtuse, will only have sine positive. Cosine and tangent are all negative. Okay, now let us move on to example 2. Okay, this is example 2. Now let's take a look. They give you all the things here, okay, and they ask you to find the various values. Now I'm going to use the basic concept to explain to you. I want to look at this part here first. Okay, this part here, the one that I have circled. Now, angle BAC. BAC is this angle. Okay, now sine of this is 8 over 17. Cosine of this is 15 over 17. And tangent of this is 8 over 15. So this is here. Okay, now next, you look at this particular part. They say they want to find sine of angle DAC, which is here, this one. Now this green angle is an obtuse angle. Okay, so if I want to find sine of this, is the same as this, because sine in the second quadrant is positive. Okay, now next they want to find cosine of the AC. Cosine of this angle, that means the same as cosine of this angle, which is 15 over 17, by a negative sign, because an obtuse angle lies in the second quadrant and the cosine is negative. Okay, because in the second quadrant only sine is positive. Now what is tangent angle ACB? Now ACB is this angle here. Tangent of this is opposite over adjacent, which is 15 over 8. Okay, this is an acute angle, so there's no problem, it's positive, 15 over 8. Okay, now I'm going to do an extension. This part D is actually an extension. Okay, now what is tangent of angle DAC? Tangent of this angle will be the same as tangent of this angle, just that it's a negative sign, because an obtuse angle lies in the second quadrant and only sine is positive. So what is the tangent of this angle? Is 8 over 15. Okay, so 8 over 15. I add a negative sign because this one is an obtuse angle and it lies in the second quadrant. So this will give you the answer to example 2. Okay, example 2. Now, I am moving on to example 3. Okay, example 3. Alright, now I need to warn you that when you do this particular chapter, you must make sure that your calculator is in the degree mode. Your calculator is in the degree mode. If not, it will be wrong. Okay, now I teach you this example 3. I did it in a different way as a textbook because this method will give you better understanding and this will be extended to your A maths. Okay, first of all, we look at this. X is between 0 and 180. That means it's only the first two quadrants, because 0 starts from here all the way here to 180. Okay, so 0 to 180. When we measure angles, it's always like that. 0 all the way here to 180. Okay, it starts from this particular line, the positive x-axis line. Okay, it starts all the way here. Alright, so this is how we measure angles. Okay, now when you are given this, you want to find the angle, you must remember to press sine inverse to give you the angle. Okay, this is done in set 2. So don't forget, answer is to 3 decimal places, truncate. So basic angle is 26.743. That means basic angle here 26.743, basic angle here 26.743. Now don't forget, let's take a look at this. Sine is positive. I have two possible angles. That means I will have 26.743 and 180 minus 26.743. That means this obtuse angle here also has got sine as 0.45. So I'll have two answers, 26.7 and 153.3 degrees. Okay, 153.3 degrees. Alright, so when you key in the basic angle, just key in this value. Alright, and you press sine inverse. You will get the answer. Now, next, I'm going on to example 3 part B. This one, all of you got to pay more attention and listen to what I'm saying. Now, cosine x is negative of this. Now, when we find basic angle, we do not key in the sine. Okay, now that's what I've written here. When we key in to find basic angle, do not key in the sine. Just key in the numerical value. So when you press cosine inverse 0.834, you will get this answer as the basic angle. So basic angle is this, but you look at the original equation. Cosine x is negative. Negative means it must lie in the second quadrant here. Okay, cosine x is negative, so it must lie in the second quadrant here, because at the second quadrant only sine is positive. So my x will be this angle here, which is 180 minus the basic angle, which is 146.5 degrees. Okay, 146.5 degrees. Alright, now I just want to make sure you know what I'm saying. When we have a basic angle, that means it's the angle that it makes. Let me just use another paper to show you. When we have a basic angle, that means this is the basic angle, okay, and this is also the basic angle. Alright, if the answer is an acute angle, this will be the answer. Okay, let's say the basic angle is theta, represented by theta. Okay, now if the answer is acute, the answer will just be theta. If the answer is obtuse, that means all the way here, it will be 180 minus theta. Okay, so I repeat, all angles are measured from the positive x-axis, and this is an acute angle. All the way here is an obtuse angle. And don't forget this thing, at this quadrant, all trigonometrical ratios are positive. At this particular quadrant, only sine is positive. The rest are all negative. Okay, now let me give you another example so that you do not seem so lost. Okay, now let me give you a numerical example again. Okay, alright, now let's say I have sine x is 0.5. Okay, sine x is 0.5. Now I will key in the calculator. I will get basic angle as 30 degrees. This is an exact angle. Okay, now sine is positive. Okay, C-A-S-T. Sine is positive. That means it's either here or here, because all positive, sine positive. Now the basic angle is 30. The basic angle is 30. So what is my answer? My answer will be here. X is 30 degrees, or all the way here. 180 minus 30, that is 150 degrees. So the final answer should be x equals to 30 degrees or 150 degrees. Okay, so this is a further example. I'm going to give you one more example. Okay, all of you take note. If I say cosine x is 0.7, cosine x is 0.7. Now, basic angle will be 45.572. Basic angle is 45.572. Now, I'm going to draw the CAST quadrants again. Now, cosine is positive. Okay, so I'm ignoring the third and the fourth quadrant because Emax only concentrate on the first and the second quadrant. So cosine is positive. I will only have the angle here. It cannot be here because over here cosine is negative. So x is just equals to 45.572, which is 45.6 degrees. All answers to degrees must be given to one decimal place round off. Okay, now I'm going to extend this further so that you are clear with what I'm saying. I'm just going to change this question a little bit. Now, what if I say cosine x is negative 0.7? Now, the basic angle is still 45.572. Okay, the basic angle is still 45.572. Now, remember, when we key in basic angle, we do not key in the sine. We do not key in the sine. Okay, we just key in cosine inverse 0.7. Then you will get this answer here. Okay, now, basic angle is this, and cosine is negative. Now, when cosine is negative, it means it's in the second quadrant. It cannot be here, because if it's here, cosine is positive. So it's all the way here, and the basic angle down here is 45.572. So what is the value of this angle? So x will be 180 minus 45.572. So it will be 134.428, which will be 134.4 degrees. Okay, now I want you to take a look at this. It is very important because if my cosine ratio is positive, it's in the first quadrant. If my cosine ratio is negative, it's in the second quadrant, and we'll have to identify that properly. But if sine is positive, there are two possible answers, because over at the first and the second quadrant, all ratios are positive and sine is positive. That's why you get two answers. Okay, now if you are still confused, can you please read through this again? Because when I assign you the homework, all of you will be knowing what I'm talking about, because it's exactly what I've said over here. Okay, now I'm going to give you your homework questions. Alright, your homework questions. Okay, it's over here. One set will be in the notebook and one set will be on the foolscap paper. Now for the notebook questions, I will not go through. You try yourself, okay? But for this set, I will go through, and it must be done on your foolscap paper. Okay, it must be done on your foolscap paper. Okay, class, that's all for section 6.1. Thank you.